We've got question 7, which is a calculator question, and it concerns a drinks company has changed their container shape from a cone to a prism. And the old design is a cone of radius 4 centimeters and vertical height 9.5 centimeters. But they've changed the design to a prism, and it has a height of h and a cross section as shown in the second diagram. But both containers have the same volume, so calculate the value of h, giving the answer to three significant figures. If you want to pause this and have a go at it, you're welcome to do so. So do so now, because I'm about to explain how to do it. The first hint I would say is in this part. Both containers have the same volume. So if you have a look at the cone should be really easy to do first of all. So let's substitute in to the equation, and we will get the equation for the volume of a cone from this volume of a cone. This is the formula list, and you get this on the front page of the exam. So let's is 1/3 pi radius squared height. I'm actually going to use VC. I'm going to put a subscript of C at the bottom. The reason is because we have a radius of the cone and of the cross section, and we have a height of the prism and a height of the cone. So the reason I'm going to use the subscripts or the letters at the bottom is so they don't get confused. So that is the formula. Make sure you copy it down right and you at least know how to use it, but you can take it right from the formula list in the exam. So it's got a radius of 4. Let's substitute and make sure you keep pi as pi instead of using an approximation. Because it's the calculator exam, your best bet is to just put pi into the calculator instead of putting 22/7 or 3.14, unless the question asks you to, but this one doesn't. The height, now you always need the vertical height, not the sloping height. There was actually a question in a past paper. I did a video on this one, but there was a question and it gave you the sloping height, not the vertical height that's perpendicular to the base. And this would be the first of the 6 marks is for that. I'm going to then evaluate this, although you technically don't have to at this stage, but it makes it a bit easier. And I'm getting 159. I'm going to check this twice just to make sure I've done it okay. Yeah, 159.17403, and the units are centimeters cubed. So that is the volume of the cone. Now what we have to do is use that information for the the prism we're told that they have the same volume, so the volume of the prism must be equal to the volume of the cone. And that's going to be, again, 159.174, sorry, 03. I want to keep a lot of decimal places or significant figures in this. If you round prematurely, then you run the risk of getting the wrong answer at the end. So you have to keep a lot more. The question does ask you to round to 3 significant figures, but that's only at the end. Again, all of these things that I point out to be careful of, I'm telling you this because I can remember being in school at the age of 14, 15, doing this same course, and I made these mistakes that I point out, I made all of them a million times back at the age of 14, so I can advise you from experience. Now, the volume of a prism is given by the area of the prism multiplied by the height. The area is the area of the cross section of the prism, and the height. So we want to find it such that the area of the cross section multiplied by the height is equal to 159.17403. And this is the second mark up to this point. Let's find the area of the cross section. We'll do this on the next page. We'll call this AP. The idea of a sector, now the cross section is a sector of radius 6 centimeters and the angle at the center is 35. The idea is it's a portion of a circle. So the formula is, to start with, it's the same as the formula of the circle. Put P at the bottom because it's the radius of the prism cross section and not the cone. We don't have to put a P below the pi because pi is a constant. It's always going to equal the exact same thing, 3.14, and so on. Then we want to multiply that by the fraction of the circle that we have. So that's going to be the central angle divided by the full 360. And let's substitute in. So we get pi times 6 squared times 35 over 360. And you would get the third mark would be for this, and for the whole line you would get the third and the fourth mark. So up to this point you get 4 marks. I'm going to then evaluate this. Again, you don't actually have to do that at this stage, but it does make it so much easier. That'll be 10.99557. What's your units? It's the cross section area we have, so centimeters squared, not cubed. So we have that. We had the formula to calculate the height of the prism. Now we know the volume, we know the area of the cross section. We want to find the height. So rearranging, we can divide. We have VP equals AP HP. Divide both sides by AP, the area of the cross section, to get HP, the height of the prism on its own. Let's take H on its own to the left hand side and isolate it. Divide both. We can substitute the volume as 159.17403. All divided by the height of the area of 10.99557. And you plug that in, you get 159.14703 divided by 10.99557, and we get 14.47620 centimeters. Watch the units. We're dealing with a height, but you have to be careful because we've had areas, we've had volumes, we've had lengths, heights, but the height is just linear, so that's just centimeters. And this would be the fifth mark is for this, and the last mark is for finding the answer to three significant figures. You always want to read the question and check, does it give you a direction on rounding? Sometimes it won't, sometimes it will. In this case, they ask you to round it to three significant figures, so you need to do that to get the last mark. Ran out of space, so I will do it. In fact, I can actually do it here. So to three significant figures, well, if we go 3 digits in, so 1, 2, 3, between the 4 and the 7 is greater than 5, so we can round the 4 up to 5 and get 14.5. And that is the last mark. So that's the final answer, rounded off. I know this one was a challenging question, but this would be one of the hardest questions I would hope to think in the exam. So best of luck with the studying, and thanks very much for watching this.